So today we're going to take a look at verifying trig identities. So first of all, a review from yesterday. So given the cosine of x is in quadrant 2, and it's adjacent over hypotenuse, so -2, hypotenuse would be 3. Find the sine of 2x and the cosine. So let's see, -2 squared plus y squared equals 3 squared. So 4 plus y squared equals 9. So y squared equals 5. So we have the square root of 5. And the sine of 2x. If I flip back in my notes yesterday, we know that the sine of 2x equals 2 sine of x cosine x. And the cosine of 2x, there were quite a few to choose from. Let's say we use the cos squared of x minus the sine squared of x. So the sine of 2x, let's see, so 2 times the sine times the cosine. So if we multiply this out, we have -4 times the square root of 5 over 9. And then we have cos squared minus sine squared. Well, cos sine squared minus sine squared. So we have 4/9 minus 5/9. So we have -1/9. So today what we're going to do is we're going to verify some trig identities. And you have to think of these as a puzzle. First thing is write everything in terms of sine and cosine. And a couple of reminders. Tangent of theta is sine of theta over cosine of theta. Cotangent of theta is cosine of theta over sine of theta. Use the Pythagorean, identities, and we can rewrite that. Right is a single fraction, so I'm going to put common denominators there. Multiply something equal to 1, kind of like, cosine over cosine, that's 1. And the key thing is don't get frustrated. Always kind of keep trying stuff. So this first one we're going to look at, we have to prove that this side equals the sine of theta. So it said write everything's in terms of sine and cosine. So sine squared of x, cotangent cosine of x over sine of x, divided by the cosine of x. We want to prove that that equals the sine of x. Well, we could simplify some stuff now. I know that this is squared. It's kind of like saying we have x squared times y over x. I should actually switch that around since sine is y. So y squared times x over y, one of the y's, would reduce out because it equals 1. So now we're left with sine of x times cosine of x over cosine of x equals sine of x. Well, cosine over cosine is 1. So we've just proved that because that side reduces down to the sine of x. So this next one here, let's see if we can multiply this out. Well, 1, because everything's in terms of sine and cosine, and this should be a cosine. 1 times 1 is 1, plus the sine of x, minus the sine of x. Then we would have minus sine squared of x equals the cosine squared of x. Well, sine and sine, so 1 minus sine squared of x equals the cosine of x, cosine squared. And well, this here, that's a Pythagorean identity. Because, and we could write this off to the side, we know that sine squared of theta plus cosine squared of theta equals 1. So therefore, 1 minus the sine squared has to equal the cosine. This next one we're going to look at, cosecant squared. So in terms of sine and cosine, 1 over the sine squared times the cosine of x, divided by 1 over the cosine of x, cotangent squared, so we'd have cosine squared of x over sine squared of x. Well, let's see. So we have all these fractions. So when we're dividing by a fraction, we multiply that by the reciprocal. So 1 times the sine squared times the cosine of x times the reciprocal of this, cosine of x over 1, cos squared of x over sine squared of x. So let's see, well, our numerator would be cos squared of x over sine squared of x equals cos squared of x over sine squared of x. Number 4, so let's start. We got the sine of x plus the cosine of x times sine of x over cosine of x equals 2 sine of x. Well, one thing I noticed right there, that's gone. So now we have sine of x plus sine of x equals 2 sine of x. Well, that makes sense because there's 2 sine of x's over here. All right, the next one we're going to take a look at. Let's see. We have 1 over the cosine squared of x minus, this would be sine of x over cosine of x times cosine of x over sine of x equals, this would be sine squared of x over cosine squared of x. Well, those all reduce out, and so that would just be 1. So now what I notice here is I have 2 terms on this side and only 1 here, so we have to make a common denominator here, and it's cosine. So I could rewrite this one, because that's just a big number 1 right there. So now we have a common denominator, and our numerator would be 1 minus the cosine squared of x over the cosine squared of x, sine squared of x over cosine squared of x. And then once again, I look here, that's a Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. So therefore, sine squared of x equals 1 minus the cosine squared of x, which is right here. So sine squared of x over cosine squared of x equals sine squared of x over cosine squared of x. Oh no, and this quit on me. So let's see if we can get this last one then here. Example 6. So this one looks quite complicated. We have all sorts of fractions here. So again, we're going to start by rewriting things in terms of sine and cosine. So the sine of A over 1 over the sine of A plus the cosine of A over 1 over the cosine of A, 1 over sine squared of A minus cotangent, cosine squared of A over sine squared of A. Well, we have all these fractions, so we need to multiply by the reciprocal. Sine of A over 1 plus the cosine of A times the cosine of A over 1. And I notice here we have a common denominator, so 1 minus the cosine squared of A over the sine squared of A. Well, what is this? This is really sine squared plus cosine squared equals 1 minus the cosine squared of A over sine squared of A. Well, sine squared plus cosine squared, that's that Pythagorean identity, so that's 1. And then once again over here, I notice that this, we have that Pythagorean identity. It's this, so 1 minus the cosine equals the sine squared. So we have sine squared over sine squared of A. So 1 equals 1. So those two are true.